Okay, we're going to do several conic problems. A water cup is 10 centimeters tall, and the mouth is 12 centimeters across. It's leaking at a rate of 10 cubic centimeters per second. And how fast is the cup leaking when there is 200 centimeter cubed left in the funnel? In other words, when there's, some left, how at that point, what is the rate of the liquid coming out? All right, so the first thing we're going to do is we've got to find our two similar triangles. So I'm going to take my handy dandy line maker and I'm going to make a red one right here. Of course, I wanted to make it where it was that way. Okay, let's try that again. Okay, it's not going to work. I got to move over 2 inches from where I need to start. So there's our red triangle, which is a big triangle. And then we have a yellow triangle, which will be I'll do it in blue. I'm sorry, not yellow. And there's that triangle. Okay, so there's our two triangles. Sorry about that. It's messing up, of course. So we got two triangles. And one triangle is blue. The other triangle is red. Now this triangle, the radius is 6 centimeters and the height is 10. And this is H, and that's R. So 6 is to 10 as H is to R. Okay? 6 is to 10 as H is to R. Cross multiply, we get 6R is equal to 10H. Divide by 6. The reason we're dividing by 6 is we want R to be our isolated variable, which is this will be 10/6. That's what, 5/3? I think 5/3 H. While H is decreasing, what is R doing? Well, as H is decreasing, as your volume goes down, as the water goes down, the radius here is decreasing because the cone is shaped where it decreases as the radius decreases as it goes down. So this rate is related to this rate. As this rate goes down, this rate goes in. So it's going like that. All right? But we've got to take this and plug it into our handy dandy formula here so we can find H and find the derivative. So V is equal to 1/3 times pi times parentheses squared, which is R squared, times H, and R is 5/3 H. I'm sorry about this stylus. I don't know why it does that, but it just puts little tags on everything. And I'm not going to write slow because I don't have time. So, we've got, clean this up a little bit because it's all nasty. V is equal to the 3, the 5, that'd be 5/9, be 5/9 pi times H cubed. Now, there's 2 or 3 things we can do here. One, we can go ahead and find H. And 2, we can find the derivative once we Well, find the derivative, and then we can find h. Now go ahead and find h if you want to. We'll say at 200 centimeters cubed, that's our volume. So volume is 200 is equal to 5/9 pi times h cubed. This would be like in the shadow problem and the ladder problem. This would be like finding your hypotenuse or finding one of your A or your B. That's what we're doing here. We're plugging this in to our volume formula so we can find h or find distance. So multiply by 9/5 and divide that by pi and take the cube root. So multiply by 9/5, divide by pi, and take the cube root. So you're left with h is equal to all of this. Now when I did the math, I came out with, let me drop my paper, I came out with h is equal to 8.1. Okay? Now that I've got h is equal to 8.1, I can take that. Probably not going to let me do this. I don't know why. Nope. Forget it. So now I got to take dv dt. I'm going to take the derivative d dt of 5v is equal to 5/9 pi h cubed. Take the derivative of that, and that's going to give me dv dt is equal to 5/9. Well, all that comes out, and that'd be 3h squared. So that's going to be 3h squared dh dt. Yes, be dh dt. So that would be, well, the 5/9 3, pull that out. That'd be 3 over 1, 5 times 9 pi, and then take the derivative of h would be 3h squared dh dt. 3h squared dh dt. So the 3 will cancel with the 9, and that's going to be 5/3 pi, I think. No, that 3 is still going to be out there. No, I brought the 3 out. I don't need that right there, so I erase that. Sorry. There we go. So that'd be 5 pi over 3, 5 pi over 3, h squared dh dt. So dv dt is equal to 5/3, or 5 pi over 3, h squared dh dt. Okay, now this is your average rate, or this is your rate of change for your volume. This is your rate of change for your height. Now what is the question asking? How fast is the cup leaking when there is 200 centimeters left in the funnel? So that means we're going to take 8.1 and plug it in for h. And we need to find dh dt. Because we know dv dt is -10. So -10 is equal to 5 pi over 3 h squared. Oh, sorry, not h squared. Well, h is 8.1, sorry. So that would be 8.1 squared. 8.1 squared times dh dt. And to find dh dt, we just, let's see, we're going to have to multiply by 3 over 5 pi. So multiply by 3 over 5 pi. And then divide by 8.1 squared. Now, when you crank all that out, I get negative 0.13 centimeters per second. So dH dt, how fast the liquid is, or the rate of liquid is falling at 300 or 200 centimeters cubed, is negative because it's decreasing. I wish this pen would write decent so I wouldn't have to keep rewriting. Sorry. dH dt is equal to negative dH dt is equal to negative 0.13 centimeters per second. I hope you can read that. Okay? Now, the next one, the next problem that we have I will put on the board. And fill it in for you. The water cup is 15 centimeters tall, and the mouth is 12 centimeters across. The water is leaking at negative 2 pi, negative 2 pi centimeters cubed per second. And this one is asking for how fast is the depth? How fast is the depth when the height is 10 inches? How fast is it decreasing when the water is at 10 inches? When liquid is at 10 inches. Okay, this is in inches, I'm sorry. Inches everywhere. Changing these as I go. A water cup is 15 inches tall and the mouth is 12 inches across. The water is leaking through the bottom of the cup at 2 pi inches, 2 pi inches cubed per second. How fast is the liquid draining at 10 inches? Okay? Hopefully y'all got that. Hopefully I ain't messed up anything. So, let's do it. So we've got the water cup is 15 inches tall. And the mouth is 12 inches across. The water is leaking through the bottom of the cup. The water is leaking at the bottom of the cup at volume. That's volume. So dV dt is going to be equal to 2 pi cubic inches per second. And they want to know how fast is the water going down, how fast is it going down when the water, or when the liquid, I'm sorry, is at 10 inches. All right, so set up your similar triangles. So I'm just going to draw these out. Here's my large one. And my smaller one I'll do in blue. There's the smaller one. And of course, like I said before, it's always going to be, this will be what, 6? This will be 6, sorry. 6 inches, because the whole thing is 12, my bad. So that'd be 6 inches is to 15 as R is to H. So 6 is to 15 as R is to H. And I don't know why this pen is doing this. I'm sorry. Maybe if I write my finger, it'll do better. So 6H is equal to 15R. And divide by 15 because we're concerned with R, we're not concerned with H. So R is equal to 2/5 H. Let's see, 3 will go into 6 and 3 will go into 5. Yeah, 2/5 H. And we're going to take that and plug it into yeah, it should be 6, yeah. Okay, I've got an error here. It's not 12 inches across, it's 6 inches across. My bad. And this is 3. Sorry, I changed it when I was doing the problem, so, you know. Okay, so I can't change it, so what I'll do is I'll just write it in blue up here. This is 3 inches. So this is 3 inches. So 3 would be 1/5. Sorry about that. And this is 3. Okay? So now set up your volume. So when you're doing the tank problems, your first step is to set up your what? Your similar triangles. Second step is to set up your volume with your new radius. So volume equals, I'm going to say pi over 3 if y'all don't mind. Pi over 3 parentheses squared times H. And the R, 1/5 H, goes in here. Now pull that 1/5 out. Well, that's going to be 1/25th. But pull it out and pull it with the 1/3 or the pi over 3. You're going to get B is equal to pi over 75 H cubed. Now, we can take go ahead and take the derivative of that in respect to time, and that's going to be d, well, I'll just go ahead and write it, d dt of v is equal to pi over 75 times h cubed. And that's going to give us dv dt is equal to, pull this out, pi over, using your constant rule, 75, 3, so that 3 is going to come out here, 3h squared, so that's going to be h squared, and then dh dt, and that's what we're trying to find. We're trying to find dh dt, I think. And we know our dV dt is right here, 2 pi. Okay? So let's write that up here, dV dt. Negative 2 pi, I'm sorry, inches cubed. I don't know why it's doing that. I don't write like that. So plug everything in, and that's the third part. Technically, you're going to take 3, and you're going to plug everything in. So, we know dV dt is 2 pi, so that would be negative 2 times pi. So negative 2 pi is equal to 3 pi over 75 times 10 squared dH dt. And now you can just bring everything over. So that's going to be 75 over 3 pi times negative 2 pi over 1. Multiply by the reciprocal, and then divide by 100, and that should be equal to dH dt. And that means if you do all this math, you should get negative 0.5, should be inches per second. So close to a ½ inch per second. And that's that problem. I've got a couple more that I'm going to give you for you to do homework-wise. And I'll give those to you on the next page. Go ahead and give them to you. And I'll pull them in. I'll pull one in right here. And I'll pull the other one in. Right here. And I'll just change this for y'all. And I'll tell you what the answer is, and you have to work and get it. Alright, so we've got water's being pumped into a cone. It's 4 meters tall. Sorry. All right, 4 meters tall. And a radius of 2 meters. So, 4 meters tall, and the mouth is, I'm just going to say 4 meters across, and then you can take out, you can do the radius. It says water is being pumped into the cone. Water is pumped into the cone. Pumped into the cone at 2 cubic meters per second. Per minute, sorry. Okay, and then it says find the rate of rising, find the rate of the liquid rising at 3 meters. So in other words, when this height is 3 meters, at that point, how fast is the liquid rising? That's what they want. So water is being pumped into a cone at 2 meters cubed, 2 meters cubed per minute. Find the rate of the rising liquid when the liquid is at 3 meters deep. Okay, so just some things that you're given. dV dt is equal to 2 meters cubed per minute, and V is equal to 1/3 pi r squared. I'll go ahead and tell you the answer on this one is 8/9 pi meters per minute. And you can check your calculator and find out what 8/9 is, but I'm not really concerned about that. All I want you to be able to get is make sure you get you set up to get those. Okay, so that's done. All right, this one is going to be here. Well, this says a cone is 3 centimeters in radius. This is 8 centimeters tall, so we can change this to 8 centimeters tall. And the mouth is 12 centimeters across. No, I'm sorry, 6 centimeters across. Water is being pumped into, pumped into the cone. Water is being pumped into the cone. Water is being pumped into the cone at 50 cubic centimeters a second. 50 cubic centimeters per second. How fast is the water rising at 4 centimeters? How fast is the water rising at 4 centimeters? Okay, I will tell you that, of course, dV dt is 50 cubic centimeters per second. It's 8 centimeters tall, and it is 3 centimeters is equal to the radius. I think I just copied the same problem. No, I didn't. Okay, sorry. Do exactly like we did. Find your similar triangles, set it up in your volume, and then take the derivative in respect to t. And that will give you an answer of, I don't know, I don't have it, 8 times 25, I think that's 200, right? Yeah, plus 4 times, 200, I think it is 200 over 9 pi. 200 over 9 pi be centimeters per second. I think I got that right. 200, hold on a minute, 200 over 9 pi, and that should be, I didn't write the units, I'm sorry, I think it's going to be centimeters per second. Okay, go ahead and work these 2 problems, and that'll be well enough for the test. Remember, I want you to be able to do a ladder. I want you to be able to do a boat. I want you to be able to do, especially the shadow. Make sure you go over that shadow problem 5 or 6 times That's why I gave you 5 or 6 problems. And make sure you can do at least 1 or 2 tanks. And be ready for the test when y'all come back. And y'all have a good weekend, good week. Talk to you later. Bye-bye.